All right, guys, welcome back to the Linux Plus preparation course. We're going to be talking about chapter 13 today. We're going to be talking about securing Linux systems. So, in this chapter, we're going to go beyond the basic administration and talk more about being, well, a system administrator. We're going to be talking about hardening our systems against attacks and ensuring that all of our data is safe. So, let's get started. By the end of this chapter, you will have a solid foundation in Linux security. We'll cover how to apply security best practices to harden a system. Now, we're going to be looking at how do we reduce vulnerabilities. We will then dive deep into securing remote access with SSH keys and understanding the roles of the advanced security models like SE Linux and App Armor. We'll learn how to configure a firewall. We'll learn how to monitor system activity like checking logs. And finally, we'll be looking at the ultimate safety net of performing data backups and verifying their integrity. These are going to be essential skills for the Linux Plus exam, so make sure that you understand these thoroughly. So before we dive into the specific commands, I want you to adopt a certain mindset. Think of your server as a fortress. It's not enough to just build the walls and walk away. You have to actively defend it. Security is not a single product that you install, it's a process and a series of layers. Now, throughout this chapter, we're going to use this analogy. A firewall is your moat, hardened servers are your walls, and then we'll access control policies as our vigilant guards. Okay. Now, encryption might even go a layer deeper, where we're going to talk about the vault, where we'll keep our treasures and other system logs like our security cameras to make sure that we understand everything that is happening within our Linux operating system. So let's start with the fundamental rules. And this is probably going to be the most important rule to begin with. Keep your systems updated. The vast majority of attacks, exploits known as vulnerabilities, are going to come through your system because you're not patched. Now, how do we fix that? Well, we need to patch our system. So one of the first commands I want you to know is going to be sudo apt update. Remember, this is going to update our catalog, and then the sudo apt upgrade to make sure that we actually apply the updates that we get in our updated catalog. Second, we need to use strong passwords wherever possible, enabling multi-factor authentication, MFA, if we can. And then lastly, we should operate under the principle of least privilege. This means any user or service should have the absolute minimum permission required to do its job. Don't stay logged in as root. Instead, use sudo for administrative tasks. This limits the damage an attacker can do if you do get a compromised account. Continuing on, you should always harden your services. Every service that is running and listening for connections on the network is a potential door into your system. If you don't need it, turn it off. This reduces what we like to call the attack surface. Next, use a firewall. This is your first line of defense against network-based attacks, and we'll talk more about this shortly. You also need to monitor all of our system logs. Remember, this is like our security cameras. They're going to tell us who's logged in, what commands they ran, and if there are any suspicious errors. And then finally, we need to back up our data. If the worst case does happen, hardware failure, catastrophic mistake, a ransomware attack, a good backup is the only thing that's going to save us. So first, let's talk about the locked vault. Let's talk about encryption. Encryption protects all that data that we call data at rest. This means if someone physically steals your server's hard drive, the data on it is just unreadable gibberish without having the decryption key. The standard tool in Linux is Lux, the Linux Unified Key Setup. There we go, LUKS. And it's normally built right into the kernel. The good news is that we don't have to be an expert to use it. Most modern Linux installers, including Ubuntu, will give us a simple checkbox during the installation to encrypt the entire disk. I do highly recommend that you enable this on any new server build. So this slide should be a bit of a review, but I want to make sure that we look at these concepts through a security lens. Identity and access management is our guards. It's all about our users, our groups, and our permissions. We need to properly configure who can access the system and what they are allowed to do, because this is going to be our absolute foundation for our security policy. Weak permissions, for example, can undermine everything else we do, so we need to make sure that we get this right the first time. For nearly every server that we're going to manage, our primary way of accessing it will be through SSH, the secure shell. This is the main gate of our fortress and is a prime target for attackers. Securing SSH is one of the most critical hardening tasks we'll perform, and the main configuration file that's going to control this is going to be found under etc. Remember, we need to be root for this, SSH, and then sshd_config. Now, inside of this sshd config, there are two changes that provide a massive security boost. First, we do not want root to be able to use this, so permit root login needs to be set to no. This will prevent anyone from attempting to log in directly as the all-powerful root user. It forces an attacker to first compromise a less privileged account and then find another way to escalate their privileges, which is much more difficult than just logging in as root. Second, the next big one is going to be turning off password authentication. This completely disables password-based logins for everyone. An attacker can't brute force a password for a system that won't even accept it. So, if you've disabled passwords, how do we log in? Well, the answer for this is going to be something more secure. We're going to use SSH key pairs. This method is based on a technology called asymmetric encryption, and it is an industry standard for securing remote access. So here's how it works. You're going to generate a key pair, which consists of two mathematically linked files. The first is going to be your private key. This key stays on your local computer. It is kept secret, and you should protect it with a strong passphrase. You must never share your private key. The second file is going to be our public key. This is the part that we can share. You copy the public key to any server you want to access. When you try to connect to the server, it's going to recognize our public key and issue us a cryptographic challenge. It's like a very complex puzzle. Only your corresponding private key can solve that puzzle. So proving your identity without ever needing a secret, like a password, over the network. Creating and deploying these keys is pretty straightforward. On our local client machine, not the server, we run the command ssh-keygen. This will generate our public and private keys, and then to install the public key on the server, we'll use a helper script called ssh-copy-id. Now this will also be followed by the username and the server IP's address. This command will securely copy our public key to the correct location on the server with the right set of permissions. After we do this, we have already disabled password authentication. We are only able to log in through SSH with the use of our private key. Now, for a more advanced topic, standard Linux permissions are discretionary, meaning the owner of a file can change its permissions. Mandatory Access Control, or MAC, is a stricter security framework that allows our operating system kernel to enforce system-wide policies that our users cannot override. Think of it like a deep security guard that even root has to obey. It puts strict limits on what processes that and what users can do, even if standard permissions otherwise allow it. Now, this is used a lot by the military, so you know this is the same type of methodology that the military uses for their top secret, and confidential clearances. So there are two major Mac implementations on our Linux systems. On Red Hat, like Fedora or CentOS, you'll find what's called SE Linux. It stands for Security Enhanced Linux, and it's incredibly powerful and detailed. It attaches security labels to every file and processes on the system. It's pretty cool. On a Debian system, the Ubuntu systems that we're used to running in this class, we use a tool called AppArmor. AppArmor is generally considered simpler. It's actually much easier to configure than SE Linux. Instead of labeling everything, we use profiles. Now, these profiles are going to define what specific applications are allowed to do. Which files can read, which ones can write, which ones can execute. And now, but just know that both programs are aimed to, well, contain any damage if a service is compromised. Now let's move to the moat of our fortress. A firewall is a program that inspects all network traffic coming in and out of our server. Based on the set of rules that we define, it can decide whether or not to allow said traffic, it can pass it, or block it. It's our first line of defense against attacks from the network. Now, there are going to be three concepts to understand. The first concept is rules. Rules are the specific definitions of what traffic is allowed or denied. For example, a rule might allow traffic incoming on port 22. Now, chains are a list of rules that are applied differently to different types of traffic. The most common chain is input for incoming traffic and output for outgoing traffic. We also have forward for any traffic that is being routed through the machine itself. Finally, we have what we call our default policy. This is the rule that applies if no other rule applies to the machine. For a secure system, our default policy should always be drop or reject. This means deny everything unless I've explicitly created a rule to allow it. Okay? Think of it like a block ACL. Now, the classic low-level firewall tool in Linux is going to be called the IP tables. It's very powerful and flexible, but the syntax can be very complex. To make things easier, Ubuntu and other distributions have now created a tool called UFW, or Uncomplicated Firewall. Now, as the name suggests, UFW is a much user-friendlier version that it manages IP rules for you. So it does help us make sure that the firewall tasks are now much simpler to manage. So here's a typical workflow in setting up UFW. First, we need to set our default policy with sudo UFW default deny incoming. This will immediately block all incoming connections. Second, before we enable the firewall, we need to open a path for like SSH. So we're going to do sudo ufw allow SSH. If you don't do this step and you're accessing the machine remotely, you will be now locked out of the server. Third, we need to enable the firewall. Sudo ufw enable. And finally, we can check the status by doing sudo ufw status. All right, now for our security cameras, the system logs themselves. Logs are the detailed records of everything that happens to our system. If we suspect something is wrong, or if we need to investigate a security incident after the fact, the logs are going to be the first place we're going to look. Learning to read them is going to be a critical skill. Our syslog. This is a system that's going to be responsible for creating most of our logs, and it's a system called our syslog. It runs in the background, collecting messages from the kernel, applications, and from any system services, and then writes all that information to a text file. Now, most of the time we're going to find these logs under the var log directory. When we look in var log, you're going to find a bunch of files, okay? But let's look at what files are probably going to be the most important. Syslogger messages contain general system-wide messages, okay? Auth.log on Debian or Ubuntu or Secure on Red Hat is going to be a critical one that records all authentication events. This is like logins, logouts, failed login attempts, and every time sudo is used. This is where you'll look for brute force attacks. We have kern.log, which contains all the messages from the Linux kernel itself, and dmessage, which shows the kernel messages from most recent boot. So these are the different logs that we should know a little bit about. All right, so we've talked about the proactive security measures, but we must be prepared for the worst. Either hardware failures, people make mistakes, security tools that are bypassed, regular and most importantly tested, are going to be our backups. This is going to be our safety net. They are the only thing that can guarantee you can recover from, well, a true disaster. Now, Linux has many powerful command line backup tools. tar is one of the oldest and simplest. It's great for creating full archives from files or even directories. rsync is a more advanced tool for synchronizing directories. It's very efficient for using regular backups because it only copies the files or parts of the files that were changed since the last backup. And then lastly, we have DD, which is a low-level tool that can create a perfect bit-by-bit image for the entire disk, which is useful for doing cloning or forensic analysis. So if you want a backup that you want to do forensic analysis on, make sure you use DD. Just know that it is going to be bit by bit. So if you have a 32 gig drive, the file that it creates is going to be 32 gigs. So you've made a backup, but how do you know for certain that the backup hasn't been corrupted or has maliciously been modified? Well, the answer is going to be using checksums, otherwise known as hashing. A hashing function is a program that reads a file and produces a short, unique string of characters. This is what we like to call the digital fingerprint. Even if a single bit in the file is changed, the hash will change completely. You can generate these hashes yourself. One of the best ones that we like to use is going to be SHA-256-SUM. This command, for example, will generate a SHA-256 hash for any file that you give it. This is a standard practice, is to create the backup, generate its hash, and store the hash somewhere safe, separate from your backup. Later, if we need to restore, We can run the SHA-256 sum on the backup file again. If the hash matches what we've saved beside, we can be confident that the file is authentic and has not been altered. All right, so let's do a quick summary of what we've learned today. Security isn't just one thing. It is a layered process built on best practices and keeping our systems up to date. We should always harden SSH by disabling direct root logins and using secure-based authentication instead of passwords. We need to make sure we use a firewall like UFW to control our network traffic and create a default deny policy. We need to monitor key files in the var log directory, especially the auth.log file for any suspicious activity. And finally, we need to make sure that our backups are regular and that all of our critical data can be verified by using integrity of backups using checksums such as SHA-256 sum. All right, that's going to bring us to the end of the chapter of securing Linux file systems. We've covered a ton of stuff throughout this class, from high-level concepts to specific commands. I hope this gives you a strong framework for how to think about and implement Linux security. Thank you. And if you have any questions, let me know. Otherwise, I will see you for chapter 14.